Continue. We're doing epsilons and deltas, the limit that is the precise definition of a limit. So better to call that we say that the limit as x approaches a of f of x is equal to L if for every epsilon positive there exists delta positive such that if x minus a in absolute value is strictly bigger than 0 and strictly less than delta, this implies that f of x minus L is less than x. Okay? This is the definition of a limit. We also did some examples last time. Let us redo one more. Show that limit as x approaches 0 of x squared. What is that limit equal to? What is that limit? 0. So, the idea, I want x squared to be arbitrarily close to what number? To 0, right? I want x squared to be arbitrary, so let epsilon be positive. Let's do it this way. So I want x squared minus 0 to be less than epsilon. What's one way of picking x minus 0 if epsilon is positive? So say epsilon is 1. So let's say it's I don't know. Let's say it's 4. Definitely, I mean let's say it's 1/4, for example. Epsilon is 1/4. If you want x squared minus 0 in absolute value to be less than 1/4, how should you pick x in absolute value? Less than 1/2, right? So if you have here root epsilon, then this is satisfied. You agree or not? Yeah. So let epsilon be positive, and delta be equal to the square root of epsilon. If 0, x minus 0, delta square root of epsilon, then x squared minus 0, which is the absolute value of x squared, is less than epsilon. And hence you proved it. And hence okay? Yes, sir. Yes, sir. Yes.
How did you use the lesson concept of less than and equal to?
Pardon me?
Why did you use the lesson or equal?
Delta is less than equal, strictly less than equal than root epsilon. Yep, sure. You can do that. Pick any number strictly less than root epsilon. That works. Right? You can pick delta root epsilon over 2. Yep, that works. Is that what you meant?
No, I meant the side. Like when you write it as the alligator side, says the alligator as the line.
Where? The what?
Like put it in a column.
Yeah, here. Here?
Yeah.
Yeah, 0 is between the absolute value of x minus 0 and delta. Pardon me?
Can it be equal to delta?
I mean, let's say no, okay? I mean, let's just say no. Okay, if you want this to be strictly less than epsilon, then well, if it's equal, is it strictly less than epsilon? Let's say x is equal to root to delta. What is x squared? X squared is epsilon, right? It's not strictly less than epsilon. Okay? Yes? Guys! Yes? Well, you want x squared to be less than epsilon, right? How should you pick your absolute value of x? Less than what? Than root epsilon.
But why do you say delta equals to?
Well, how close does x need to be to 0? Delta away, right? If delta is root epsilon, if you have this, then you have that. Such that if x minus a is less than delta, then f of x minus L is less than epsilon. It's not the only epsilon, it's not the only delta that works, right? You can take root epsilon over 2. Okay? Great. Let's do it. Yes, sir.
What are epsilon and delta represented?
Sure. The definition of a limit states that you can make f of x arbitrarily close to L by making x sufficiently close but not equal to A. Okay, so here we can play a sort of game. I can tell you how close I want f of x to be to L. That's represented by epsilon. I can tell you how do you choose x so that f of x is 1 unit away from L. And then you have to tell me, well, if you want x squared to be 1 unit away from 0, you have to choose x to be 1 unit away from 0. Okay? That's a delta. I give you an epsilon, and you have to give me a delta. Technically, usually. Okay? Yeah? Yeah. So, if I give you an epsilon, you have to give me a delta, for which the difference between f of x and L is less than epsilon. Okay? Let's do one more example. And finish it up. Okay, we did one. Let's see. Should we do a harder one? Let's do a hard. Let's do something else actually. Okay, show let A be a positive number. Let's root A using the epsilon delta definition. Okay, maybe let's put a number. Let's put a number here. It's going to be easier. It's fine. It's not a big deal. You can do it with any number. Okay, great. Now, how do I proceed? I need to bound the difference root x minus 2. Now this is a bit difficult, right? I need to look at this difference. F of x, this is f of x, and this is L. Now what's one way of doing this? I can just multiply by the conjugate on top and on the bottom. You agree? Did I do anything wrong here? No. Great. The idea is that I want to look at this difference and let that x minus 4 appear. Now, does x minus 4 appear on top? Look at on top. X minus 4 appears, right? When you just expand that. And on the bottom, you have root x plus 2. Agree? Everybody. Now, what is the problem here actually? What is the problem? So, the root x is really bothering you a bit, right? You agree? The root x is bothering you on the bottom. Now, how do we get rid of that? Root x, is it a positive number or a negative number? It's a non-negative number. I mean, here as x approaches 4, it's a positive number. So I can say that this is just less than x minus 4 over 2 in absolute value. You agree? Do you agree or not? Great. Now I want this thing to be less than epsilon. If I give you an epsilon positive, I want this thing to be less than epsilon. In what way could I fit my x minus 4 so that this holds? It's less than 2 epsilon, right? You see that? You guys see that? If I pick my x minus 4 to be less than 2 epsilon, then my f of x minus L will be less than epsilon, right? You guys see that? Let's do that. So let epsilon be positive. And delta, which guys is please be 2 epsilon. If x minus 4 in absolute value is between 0 and delta, which is 2 epsilon, then f of x minus L, which is root x minus 2, what is that equal to by dipping on there? it's equal to the absolute value of x minus 4 over root x plus 2, and this is, well, I mean, strictly less, but it say less than or equal to x minus 4 over 2, which is strictly less than delta over 2, and delta over 2, 2 epsilon over 2, which is epsilon. Hence, x approaches 4 of root x is equal to 2. Okay? Great. Yes?
How do you limit the square root of x from the bottom of
Sure.
the fraction on the right?
You agree that this is less or equal than that, right? If I make this thing less than epsilon, what happens?
Well, it comes close enough to 0 then. Well,
Exactly. So if I make this one less than epsilon, then this one is less than epsilon. You see that? If the bigger term is less than epsilon, then the smaller term is less than epsilon. Right? Okay, it's not easy, but we have a lot of problems in the book. So I invite you to do that. And now let's move on. Okay? Any questions? Any questions? Someone had a question here and I did not take it. So someone else. I don't know, they had a question. Anyways, okay, go ahead.
Do you mind writing down the definition of epsilon and delta? Because I don't get it.
Okay, so what is epsilon?
Not the definition of like a just what they represent.
Sure. Epsilon is how close you need epsilon is given, right? What is the definition of a limit? The oral definition, the informal definition that we gave. We can make f of x arbitrary close to L, right? What is the arbitrary close to L? So basically you say that you want f of x to be epsilon away from L, right? This is what it means. Arbitrary close to L. Right? You can give me epsilon. You give me. So you say, I want epsilon to be 1 over 100. And then I have to tell you how close x should be to A. By making x, you make x sufficiently close to, but not equal okay? By making. So when you say by making, basically you choose the delta. Okay? Yeah.
What point do you know that you're prove that?
Once you do that, then you already proved everything. You proved that the limit of f of x is equal to L.
Like,
Is there a?
is there like any criteria that you have to follow?
No, just when you reach this, where? Yeah. Once you have that f of x minus L is less than epsilon, if x minus a is less than delta and bigger than 0 in absolute value, then you already did this. Okay? Great. Yeah. Guys, yeah. Pardon me?
In the previous question.
Yeah. Yeah. Can you just
Use one-sided limit.
why?
Easier.
No, the question does not involve one-sided limit. It involves one limit. Right? Did I specify an approach is 0 plus? No, I said an approach is 0. Okay? Yeah?
Can you describe the exact proof at the end that you're looking for us to state? Like,
This.
yeah.
This is the proof that I'm looking for you to state. Let epsilon be positive, and you choose the delta. If this, then f of x minus L is less than epsilon. That's what I want from you. Okay? Great. And I mean, are we using limit laws here? No. The question we're saying, using the epsilon delta definition of a limit, show that this is true. Okay? No, for other examples, you can use the limit laws, of course. Does it have to do with this? Okay. Like we did in class, do understand. Okay? Yeah. Guys, yeah. In general, or in math 140? In general? In general, if you want to prove that the limit is unique, for example, you use epsilon and delta. If you want to prove the limit laws, you use epsilon and delta. Yeah? Guys, please. Yes? It's not a relationship. Well, it's a relationship, sure, but I have to give you epsilon, and delta should be in terms of epsilon. Okay? It's not like epsilon can depend on, delta depends on epsilon. Well, so let's not talk about the limit is not there. Exactly. So you have to take the contrapart. Yeah. Anyway, you have to take the negative statement. Okay? Like, yeah, this statement for all epsilon there exists delta such that blah 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 must not be satisfied. Okay? And I invite you to think, how is it not satisfied? Okay? Okay, any more questions? Great, awesome. No more questions, let's move on.
Oh, wait, I have a question.
Yeah. Guys, please, yes. Why couldn't the denominator be 1? Should be 1. Where, sorry, here? You mean there? Yeah, could be 1.
Then epsilon is equal delta.
Yeah. Let's see. Yeah? If delta is equal to epsilon, yeah, sure. Oh, wait a second. Yeah, sure, yeah. Could be 1. Delta is not unique, right? Guys, please. Everybody, somebody is asking a question. Yes. Okay? Delta could be epsilon. That's right. Delta could be epsilon. Then let's double check that. So you're saying that let's see. This is true, right? You agree that this is true? Yeah, I think that's good. Yeah. Yeah. So you say that this is less than x minus 4. Yeah, that's fine. You can pick delta as epsilon. That's totally fine. Yeah. That's totally fine. Okay, the idea here. Okay, yeah, okay. Anyway, let's move on and continue the derivatives. Let's start with derivatives. Any questions? Someone here had a question? No? Okay, great. Okay. We're all good with this? That's fine. You'll get used to it. Okay, anyway. Yeah. Pardon me?
Will we ever have to prove that it doesn't rise epsilon 0? Will it ever be false? Will it be
No, so you will always be able to get to that.
Will always epsilon A, what is given will always be given epsilon 0?
You have to find the delta.
No, I get that, but I'm saying will you ever give us
Guys, please. It's not nice. Somebody's talking. It's not nice that you're talking. Yeah.
Will you give us an equation where what the aspect is approaching is not between epsilon and 0 and prove that it's false?
No, so, I will give you proof that limit as x, find limit as x approaches 3 say of x squared, and prove it using the epsilon delta. Okay? Like, you will have to do this.
Yeah, no, I get that, but I think like, will you ever make it a case for like, what, the equation is approaching is higher than the given epsilon?
No. No. Okay, you'll always be able to get it.
Okay, you'll always be able to.
Yeah. Okay, great. Now let us look at the derivative. Very nice. Now let us start a new chapter or a new section in this chapter. I think this is where the course. I mean, everything is important in the course, but this is where the course really starts. Not really starts, but this is an important notion of the course. It's better that you get it, because here, if you start not getting stuff, things will start to pile up. Okay? So please try to stay on top of the material. Of course, for example, if you don't get epsilon delta, sure, you may miss a question. That's fine. But it won't, like, affect everything. But here, if you start, like, not understanding and just, not taking action, then it's going to be a problem. Okay? So this is one of the most important topics that we'll discuss, the derivative of a function. Now, if you remember in the first lecture, how did you define the notion of limits? You had a curve. I'll draw the line y is equal to x squared. And you fixed a point, let's say the point 1, 1. Right? Is that how you did it? And then, you drew a, well, let's see, that's fine. You drew the secant line between the point 1, 1 and a point, let's say, I don't know, a squared. You remember that? Yeah? And then you look at the slope of this line. So, well, let's call this, wait a minute. Let's call this A, and this is f of A, right? This is the point A, f of A. And this is an arbitrary point, let's call it x, although it's let's call it x. X, f of x. Okay, and you let x approach A. What is the slope of this line? You know what's the slope of this line? The difference in y, right? Slope of this line is delta y over delta x. What is delta y? It's f of x minus f of A divided by x minus A. Right? You see that? Now, if x is approaching A, if x is getting close to A, what do you expect the slope of this line to be? Now let's see. This is the point A, f of A. And I'm letting x be closer to A. right? If x is getting closer to a, what do you expect? How do you expect this line to be? Do you expect it to be tangent to the parabola? Okay? So take x to be closer to a, and then your line should be something like that. Whenever you make x very close to a, your line should be like this. Now, by making x closer to a, what operation I'm doing here? What is the thing I'm doing? Take x close to a. Yes, a limit. So the slope of this line, the slope of the tangent line, is the limit as x approaches a of f of x minus a over x minus a. Now try to plug in. Suppose that f is continuous, say, and try to plug in. Try to evaluate this. What do you get on top? What do you get on top? 0. What do you get on the bottom? 0. Could you evaluate this? What is that? It's an indeterminate form. Okay? So limit as x approaches a. So let f be a function. Be a function defined on an open interval around a. We say that f is differentiable at a is if the limit as x approaches a of f of x minus f of x divided by x minus a exists. We write, for those who have seen this, we denote this limit by f prime. Okay? Do you agree? This is the definition. Have you guys seen this before? How many of you have seen this before? Now, yes. Oh, you're just saying that you've seen it. Okay, yeah. Okay. Okay. I don't think it was that funny. Okay. Anyway. Okay. Now this is the definition. Great. Now, you're taking x close to a. What's another way of rewriting this? So if x is close to a, let's redraw the graph. I'm saying that x is close to a. What if I write x as a plus h? Okay, just write x is equal to a plus h. And you want x to be close to a. Where should h go to? Technically. Do you guys see that? Do you guys see that? Write x as a plus h. We then have, we also have so I'll not write the limit, but I'll write a plus h. Replace x by a plus h. What do we get here? What does x minus a become? X minus a becomes if x is equal to a plus h, what does x minus a become? H, right? F is f a plus h minus f of a or h. Now if x is going to a, where is h going? Do you guys see that? If x is going to a, then h is going to 0. You guys see this? Yeah. Both of these definitions are equivalent. Okay? Both of these definitions are equivalent. Okay? You can use this one, x approaches a of f of x minus f of a over x minus a, or f of a plus h minus f of a over h as h approaches 0. Okay? Great. Let's give an example. So that f of x equal x. Who wants to give me their favorite number? Favorite number? Yes, Bet? Yeah. 8. So that f of x is differentiable at 8 and find a prime of it. How do you do that? You have to take the limit. Which one do you prefer? This one or this one? Let's do the left hand side, the left one. Great, let's do that. So I have to take the limit as x approaches 8 of f of x minus f of a over x minus 8. What is f of x here? Everybody, what is f of x? X. So it's the limit as x approaches 8 of x minus 8 over x minus 8. What is that limit? Everybody, what is that limit? What is that limit? 1. Is f differentiable at 8 or not? Hence, f of x equal x is differentiable at 8. I mean, I don't like f of x equal x is differentiable, but that's fine. We should write f is differentiable at 8. And that prime of 8 is equal to what? Is equal to 1. Are we good? Are we good? Should we do one more? Let's do one more. Let's do it using the other definition, or let's try another function using the other definition. Favorite number? Who wants to pick their favorite number? Yeah? Wait, who raised their? I think I asked the one behind. Yeah. 6? Okay. Yeah.
7.
No, she said 6. Okay. Yeah. So x minus 8 over x minus 8. So show that. Or let's do a question. If f of x equal x squared differentiable at 6, sorry. If so, find the prime of 7, of 6. Okay, now notice, I know many of you have seen the rules of derivatives. Okay, but usually there is a question, use the definition of the derivative to do something. Whenever we say use the definition of the derivative, you have to find this, you have to take this approach. Okay? The limit approach. Great. So what do I have to do here? I need to evaluate the limit as x approaches 6 of f of x minus 6 over what? Over x minus 6. What is f of x here, everybody? Everybody, what is f of x? X squared. What is f of 6? What is f of 6? 36. So I have x squared minus 36 over x minus 6. What is that? So I try to plug in, what do I get? 0 over 0. What can I do here? I can factor the top into x minus 6 times x plus 6. X minus 6 here. I cancel out the x minus 6, and I'm left with x plus 6. And what do I get? 12. Is f differentiable at 6? What is f prime at 6? 12. So f is differentiable at 6. Okay, are we good here? Okay. Should we do, yes?
So if it isn't differentiable, what would you get?
That's right. So if that limit doesn't exist, we say that f is not differentiable.
Okay, but, so, okay.
Let's do an example. Very good question. Let f of x be equal to your favorite function, which is the absolute value of x. Okay? Is f differentiable at 0? What do you have to look at here? I'll see this. We'll have to look at the limit. What is this limit? As x approaches what? Everybody, what is the limit I'm looking at here? The limit as x approaches what number? Everybody, who wants to help? 0 of what? What is the difference I'm looking at? What is the quotient I'm looking at? F of x minus f of 0 over x minus, very good, f of x minus f of 0 over x minus 0. What is f of x in that case? What is f of x in that case? Absolute value of x. What is f of 0? What is f of 0? Absolute value of 0 is equal to what? 0. So absolute value of x minus absolute value of 0 over x minus 0, which is just the limit as x approaches 0 does that limit exist? Does that limit exist? Let's have a look. So really, let's try to evaluate. The goal is, what is annoying me here is what is annoying me? The absolute value. So I'm going to try to get rid of them. But you know, I can't really get rid of them unless I specify whether x is positive, going to 0 for the while remaining positive, or negative. Now if x is going to 0 from the right, so x is positive, what is the absolute value of x? It's x, right? Absolute value of a positive number is the number itself, right? You agree? Absolute value of 5 is 5. Absolute value of 0.1 is 0.1. So the absolute value of x if x is positive is equal to x. What is that here? 1. Great. Now let me look at this limit, but as x approaches the limit of this function, but as x approaches 0 from the left. So x approaches 0 while remaining negative. If x is negative, what is the absolute value of x? It's minus x, you agree? Pick a negative number. Your favorite negative number? Who wants to volunteer for a number? Yeah? Negative 5. What's the absolute value of negative 5? 5. What's the relation between 5 and minus 5? 5 is equal to minus 5, right? You agree with this? Yeah. So the absolute value of x in that case is minus x. And what is this limit? Minus 4. Does that limit exist? No. It does not exist. Then we have that. So is f differentiable at 0? No. Okay? Is not. Differentiable at 0. Yeah. How do you show? Well, in that case, it's going to be the same. Yeah, because you have f of h minus f of 0 over h. No, I'm saying in that case. In that case, it's going to be the same. Yeah, you'll have absolute value of h over h. Okay. Let's do an example. So, let's do an example with the h definition. Great. Okay. Show that f of x equal 1 over x is differentiable at a equals 2 and find f prime of 2. Okay, let's do that using the h definition. Oh, did I read it? Oh, okay. Let's see. So what do I need? I need the limit as h approaches 0. Let's rewrite it here. Of f of a plus h minus f of a over h. Let's have a look at that. So what is this? F of 2 plus h minus f of 2 over h. Great. What is this? What is f of 2 plus h? It's 1 over 2 plus h, right? Minus 1 over 2 over h. Now what do you do here? Try to plug in. What do you get? 0 over 0, right? What do you do here? How do you evaluate this limit? You try to clean up the numerator, right? You put the numerator is itself a difference of two fractions, so you try to put them in a common denominator. So let's see what's the common denominator. It's 2 times 2 plus h. So you multiply the first fraction by 2, and you multiply the next fraction, the second fraction by 2 plus h on top and on the bottom, divided by h, right? Really, we're just doing limits here, right? We're not doing anything difficult. Do you agree or not? Yeah? What happens here? Let's see. I have the limit as h goes to 0 of... Could I do it quickly? Do you guys see if I subtract the 2, I'm left with minus h or not? Do you guys see that? Yeah? If I subtract these two, I'm left with minus h on top. Minus h over 2 times 2 plus h divided by h. And what is that? This is equal to the limit. As h goes to 0, let me write it in a nice way. Over h. I still have my 0 over 0. I didn't do anything yet. What can I cancel out though? The h is out. And what am I left with? I'm left with minus 1/4. Okay? Really, finding the derivative is just dealing with a limit of the form 0 over 0. And do you know how to do this or not? We've done this, right? 0 over 0 limits. We've done this many, many times. Okay? Yes?
On the exam, when it asks us to derive using limited notation, can we use one or the other, or should we memorize?
One or the other. Yeah. I don't think we'll say use this definition. Yeah. No. Both of these are equivalent definitions. Yeah. Yeah.
Are there cases where using one or the other is easier?
Depends. Everybody has a. I prefer that one because I find it easier. F of x minus f of a over x minus a. I find it easier, but some people don't. So, okay. Usually. Okay. Well, this is a good question. This one is nicer on top. F of x minus f of a is nicer than f of a plus h minus f of a. But h is nicer than x minus a. Both of them are equivalent, but you know, it's a matter of taste. Okay? Any questions? Can we move on? Yeah, is that clear? Is that clear? Should we do one more example? Let's do one more example. It's differentiable. Find f prime of 4. Let's do that. Let's do that. Oh, look, I shouldn't have done that, but that's okay. Should have already upstairs. I need to look at the limit of what? As x approaches 4, of f of x minus what, everybody? Minus. F of x minus. Everybody, f of x minus. F of 4 divided by x minus 4. Okay? What is that limit? What is f of x? It's root x minus root 4 over x minus 4. What is that limit? Let's simplify root 4. I mean, we don't have to, but it's better. Root x minus 2 over x minus 4. Try to plug in, what do you get? 0 over 0, right? What do we have to do here? How do you solve that limit? Forget about derivatives. How do you solve that limit? Multiply by the conjugate, which is root x plus 2 on top and on the bottom. That's very good, thank you. Over x minus 4 times root x plus 2. What happens here? The top becomes x minus 4. The top becomes x minus 4. Great. Did I get rid of my 0 over 0 or not yet? Not yet. What can I do? I can cancel out the x minus 4. Okay. So what am I left with? 1 over root 4 plus 2. Yeah, so it's 1 over root 4 plus 2. So it's 1 over 4. So f of x is differentiable at 2 and at 4, sorry. And f prime of 4 Okay. Great, thank you very much. Practice this and see you on Friday.